Hey everybody, this is Brad Dyke saying hi, how are you doing? And today we're going to talk about something that is kind of boiling on a lot of our minds. When you have an IT test lab, you may also have what you would consider a utilitarian server that can provide, oh, I don't know, maybe VM instances, or it could provide you storage capacity or web services, things like that. But it's a server that you reconstituted and it's a hefty, nice looking server. Or in this case, it's a server that I redesigned myself. I built this box on a different principle than in my test lab environments. Now, the guideline behind this is so that we can basically take a fairly decent box, like a Dell 720 XD or something like that, uh, or let's say a powerhouse system, but yet it's in our home, 1400 watts, a lot of power to use to take advantage of this. And in most test labs, we spin up our equipment, we get it running, we do our tests, and then we shut it down because it's just too expensive to maintain a data center in your home. But you have that one box that you do like to have on, and in my case, it is a Dell 720. I happen to be partial to because it has a great capacity. But in this video, I'm going to show you how you can take a large chassis, or like a 4U or a 2U chassis, that's a pretty hefty, powerful box, and scale it down. That's an important detail when you're trying to conserve energy but yet still meet all your needs. So the first thing you want to do is you want to genuinely look at your workload. In here, we have a baseline chassis. It's a Series 5000. It's got a back-end processor, which is okay. But this particular type of processor is known as what is called a low consumption processor. Many motherboards that you have out there will have this option. With this option, you can actually go to the actual footprint of the motherboard spec and go to the lower processors. They're not necessarily weak, they just don't consume a lot of energy. And that's not a bad step to take. So in this case, this is a low C Power 4. It's basically a Xeon. It's a 3200 series processor stack. It's a very capable functional unit. And all it's going to do is to do some coordinations with a core service or two. So I don't need a lot of CPU power. Another thing that which is valuable is to make sure that you are looking at your air control. High air control actually can be a fairly decent consumer of energy. So looking at this means that, hey, if I have on my system a Dell 720 and it's a dual processor, I can clear one of my processors out, put a base receiver in to cover the second processor like you see here. And by doing that, I only need so much computation for my storage capacity. And so by doing that, I can actually cut out some of that CPU time. Now over here on my banks, I have basically 4 and 4. So 4 is dedicated to CPU 1 and 4 is dedicated to CPU 2. Unless it's a single busing mode, it will go back to the first processor. So this is okay. RAM is good, but understand, get the RAM you need. You don't necessarily have to have a lot of RAM because we're also trying to save costs. Now the power supply will provide to you what you need as what you have to have. That's a critical detail. It will drop in voltage if it doesn't have something drawing a lot of power. So even though this is a 2U footprint server which I have running, and I have consolidated airflow with 2 hard drive capacities at 3.5 inch and 2 of my SSD models, and this is a design I built, which I can house a variety of different disks. This gives me the ability to be able to do what I want to do, and that is have some basic redundancy, basically 2 pairs of drives, each in RAID 1, even airflow, and basically I have a good overall performance matrix here that will do the job. And you can actually buy empty housings. Matter of fact, I made a video on empty housing cases, and I transformed them into something pretty impressive. But today we're talking about how can I take something I buy on eBay and dumb it down some, get the power consumption ratio under control. And then that leads me to the next big thing that takes power: your hard drives. Yep, that's true. Your hard drives. So let's say this Dell PowerEdge 720 chassis here that I've got is basically a chassis that is been reduced. I only need the memory I need to do what I want to do. I only have one processor on board, and I'm using a low series power consumption Xeon processor. Now all I have to do is deal with the capacity of my disks. Yes, believe it or not, spinning disks doesn't take as much energy as SSD disks do. As you can see down here, I have my SSDs. These are all SSD drives, and they draw more power than spinning disks because of two reasons. One, spinning disks have a greater evolution, so they have better basic BIOS and start matrices designed to save power consumption ratio. So that's important. But you also have heat. More heat, more RPM speeding up, again, eating up more watts. So how do we defeat this? How do we get this under control? Easy. Number one, I know it may sound cheap, but buying small capacity hard drives in large number, if you want to use it for your personal use, is not a good answer. Buy bigger disks and space them incrementally between each other. Give a space to the left and give a space to the right. Remember, you still have to have your air inductions. These are your air inductions. These are basically spacers designed to evenly distribute the airflow to the front of the chassis so that every device gets the cooling power it needs. But space them out. Now, this basically causes the CPU fans, and in this particular chassis, I think I have like 6 fans. 3 on this side and 3 on this side, and they're sucking air and they're blowing it through the processor and the memory and all of that, and that allows them to maintain a level of coolness. By controlling the nature of your airflow, how many processors you have, how much spacing you have on your hard disks, breaking them apart is what you should do. And also make sure that you're taking a few extra steps to make sure that peripheral cards that are put on board are also AP compliant, that's Advanced Power Management compliant, and that your interfaces are going to accomplish what you want to do. What is that? Use less power. So this chassis is actually not a bad chassis at all. It's one of the best chassis. It's an S5000 series Intel motherboard with the low power consumption Xeon processors, and it's a great tasker. It doesn't have to do a lot. You put 2 10 terabyte or 15 or 20 terabyte drives in here in RAID 1 configuration that use a spinning disk format, and you've got capacity with a good AMPCL or a compliant NIC card interface on the back end, which will give you the ability of providing connectivity as you need, but also powering down when it's not needed. And of course, you can utilize some other technologies such as better control airflow and better spacing. You can turn this chassis, this metal chassis frame, into a distribution heat sink. And again, the cooler things run, the slower the fans will run. And you want to make sure that you're considering that. So it's important to understand that when we have our IT labs, when we do our IT stuff, we bring stuff up, we test, we shut it down because we just can't afford that bill at the end of the month. And we try to keep this stuff somewhat marginally under control. But if you want to have a Plex server, or if you want to have something beyond that of what we call a basic device, and a basic device is basically a NAS device, as you can see here, 4 drives. This is probably the best recommendation model you can have out there. And a NAS device is nothing more than network accessible hard drives. But if you want to step up one step above that, then consider the nature of taking a decent chassis that's fairly powerful, structural it down to a lot less workload capacity to meet what you need every day, through the week, through the month, because of 2 principal reasons. One, it's not if your stuff fails, it's when it fails. Never forget that. And the important thing is here is that you understand that, yeah, you want to save money, but I want to have a Plex server, or I want to have a feed server, or I want to have a hyperthread slash TrueNAS kind of footprint, or something like that. You can do that, and you can do it on the low dime. it's tempting to make that mistake of getting stuff off of eBay just as it is and running it in its capacity and realizing, oh wow, this is getting expensive. So with that being said, the key detail here is to understand you can get that stuff on eBay and you can take it and take it to a new level by getting down to 250 watts, 190 watts, 100 watts, which you can afford that cost. That's a real legitimate cost that is going to be able to give you some resources you could have on hand 24/7, but not incurring the expenses of having, let's say, a quad array up and running. I'll go into that later because I do happen to have a quad array and I like the power I've got. This is Brad Dyke signing off. I hope you enjoy. Keep tweaking this stuff out, reinventing it, keep having fun. That's the whole point. God bless.